On this slide, I'm presenting the general procedure for determining the properties of an existing microstrip line. By this I mean we've got a microstrip. It's on a printed circuit board. It's got a fixed dimensions, and we want to determine what the characteristic impedance of that microstrip transmission line is. The first is that we have to know a little bit of information about the printed circuit board itself. We have to get the nominal dielectric from the data sheet. So what that means is we need to find the relative electric permittivity of the dielectric material. We then use the formulas that we presented on the previous slides to calculate the effective dielectric material constant there. So we'll then measure the trace width, which is just in the cross section of the T line. That is W right there, the width of the trace. And then we will measure the height of the substrate material. The width of the trace is set by the designer. The height might come off of the data sheet that might be provided to how thick the substrate material is. And then we just determine the W to H ratio. So just divide W by H. Based on the W to H ratio, we can calculate the characteristic impedance Z0 of the transmission line using one of these two equations. If W divided by H is less than 1, we're in the high impedance regime, and we use the equation here. And if W divided by H is greater than 1, we're in the low impedance regime, and we use the equation here. You can see that the only numbers that are necessary for both of the equations are the effective electric permittivity, the height of the substrate material, and the width of the signal trace line. So although the formulas are different in both of the cases, the inputs to the formula, the independent variables in the formula, are exactly the same. So that's microstrip analysis. And the other condition we might find ourselves in is designing a microstrip transmission line. And so if we have known printed circuit board material and we want to design a microstrip T-line, what we have to do is we have to determine our W to H ratio. And so we've got some equations that allow us to do that. So the first thing is that we need to find the substrate height and the dielectric constant from the data sheet. So that gives us H and epsilon R. We then use a tool called the Microstrip design chart to get a rough estimate of the necessary W to H ratio to achieve the desired impedance. So we use this, and I'll show you how to use this tool to get an estimate of the effective W to H ratio. If the estimated ratio is greater than 2, if the estimated ratio we get from that microstrip design chart is greater than 2, we're going to use these low impedance design equations. And otherwise, if the W to H ratio is less than 2 or equal to 2, we're going to use the high impedance region, which are these design equations over here. The width of the trace for the given impedance is determined by multiplying the calculated W to H ratio by the substrate height. We can also determine the length of the trace that we need to get that Z0 by using the calculated W to H ratio and the effective dielectric constant, the velocity of propagation, and the wavelength of the signal. I mentioned this a design chart for W to H ratios. So this chart can be used to determine approximate W to H ratios based on the desired characteristic impedance. So what you see here is that on the vertical axis, we've got the characteristic impedance that we're looking for. And along the horizontal axis, we've got W to H ratios. And we've got a boundary at 2 with the low impedance region and the high impedance region. So these curved lines represent relative permeabilities. You can see that here we have a relative permeability of 1, and as we move in this direction, the relative permeability increases. So this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this chart is plotting relative permeabilities anywhere from epsilon r equals 1 all the way up to epsilon r equals 10. And all you do is you will find, you'll take your desired characteristic impedance of your T-line, you'll draw a straight line at that value across the, that's not a very straight line, but imagine it was, and you'll draw that straight across, and then what you do is you find where it intersects with the relative permeability of the circuit board material that you're using. So let's say that our circuit board material has a relative permeability of 2. That intersection is here, and it shows us that we are, since we're on the right-hand side of this line, we're in the low impedance region. So on our design equations, we would use these since we're greater than 2. So that is the use of approximate W to W to H ratios from the Microstrip design chart, and I've provided a copy of this chart for you in the Blackboard content online.